In this video, we are going to be talking about operations with polynomials. First, we are going to begin with adding and subtracting polynomials. The first step is to look for the operation. To make sure that we know if we are adding or subtracting, you find it in between the polynomials. We are going to do that operation to combine terms from each polynomial, but make sure to be very careful when subtracting. It may change your signs. And then our answer needs to be put into standard form. I'm going to show you on example A what we do. We start by looking at like terms. So we have k cubed and a 6k cubed. And then I'm going to look at the sign and it tells me that I should add those two terms. Well, k cubed plus 6k cubed is 7k cubed. Then I'm going to look at my next terms. I have a -3 and a 5, and I need to add them. When I add them together, I get a +2. The other type of example, the other type of operation, we can see in example B. In this example, we have like terms of 8p and p. This time, I want you to notice that we are subtracting. 8p minus p is 7p. Then when we look at our constant terms, we have a -5 and a -7. But because when we are subtracting, we need to remember that we are going to have -7 minus a -5, which becomes -7 plus 5. And the solution to that is -2. So the answer to this polynomial is going to be 7p minus 2. And that is a simple example of how you add and subtract polynomials. Moving on, the other polynomial operation that we perform is multiplying polynomials. Multiplying polynomials is like using the distributive property. We're just going to use it twice, and then we combine like terms to finish. For example, when we have two variables of the same type and we add them, we get 2a. But when we multiply them, they become a squared. Let's look at this next example. A squared is a times a. We know that from the previous example. And we're going to multiply a third a. That is going to give us a to the power of 3. Then in the last example, we have 2 times a times a times a times 3 times a times a. I can look at the terms of 2 and 3 and multiply them to get 6. And then I have 5 remaining a's being multiplied, so I have 6a to the power of 5. Let's look at the example B. I like to use the box method when doing distribution because it helps me keep track of all the terms. So the first expression, 5b squared and 2, I'm going to enter on the left side. The second expression, 7b minus 6, I'm going to enter on the right side. Then I'm going to perform some multiplication. 5b squared times 7b is 35b cubed. 5b squared minus 6 is -30b squared. 2 times 7b is 14b. And 2 times -6 is -12. When we look inside the box, I want you to notice that this window pane right here kind of resembles a big plus sign, and that's what we're going to do to the terms inside the box. In this particular example, none of our variables have the same exponent, so there is nothing that we need to combine, giving us a final answer in standard form of 35b cubed minus 30b squared plus 14b minus 12. Not all our examples will be like that. Let's look at example A. For this purpose, we're going to just look at the terms and not worry about the negative right now. So what we're going to do is make another box. We're going to put the first term on the left, so we get y and -3. And then we're going to put 2y plus 5 on top of the box. Then we're going to multiply the terms. Y times 2y is 2y squared. y times 5 is 5y. Negative 3 times 2y is negative 6y. And negative 3 times positive 15, or positive 5 is negative 15. I was getting a little ahead of myself there. If you look in this box, we have 5y and negative 6y. Those variables have the same exponent. So we are going to go ahead and combine them when we write it in standard form. So we have 2y squared, negative 6y plus 5y gives us a negative y, and then negative 15. And that is how you do distribution using the box method.